welcome back to today's Vidyanagar online science class. And I'm here with you to continue our 10th chapter, Gravitation. We are going to start a new chapter, Gravitation, and at the end of today's class, you are going to learn 3 points from the chapter Gravitation. They are centripetal force, gravitation, and universal law of gravitation. These are the 3 points we are going to discuss in our today's class. Which are the 3 points? Centripetal force, gravitation, and universal law of gravitation. Let's begin. Okay? Yes. The planets are revolving around the sun and the moon revolves around the earth. High tides, low tides. When we throw an object up, that object is falling down. The coconut falls down, apple falls down, mango falls down. So, can you see, is there anything common in these examples? Is there anything common in these examples, like planets are revolving around the sun and the object or whatever objects, when we throw it up, it comes down? Definitely, in these examples, we can see a common force. We are going to discuss about this common force in our today's class. Okay, before describing about this common force, we can discuss another point. Okay, which means, you may heard about Newton's story, right? When he was sit under the apple tree, an apple fell on him. And the fall of an apple made Newton thinking. And as a result of his thinking, he found out very, very important concept. We will discuss about this important concept in our today's class. So, keeping your mind about Newton's, story, when he was sitting under an apple tree, an apple suddenly fell on him, and the fall of an apple made Newton thinking. As a result of this thinking, he found out some new concept. Okay, and before that, let me, introduce a new point to you. Like, look at the picture on the screen. What you can see on the screen? A boy, moving a stone tied and thread in the circular path. What you can see on the screen? A boy is rotating a stone along the circular path. A boy is rotating or moving a stone along the circular path. See, when an object moves along the circular path, there is change in velocity or acceleration. Change in velocity or acceleration. When an object moves along a circular path, there is change in velocity or acceleration, but that change in velocity is constant. That is, uniform circular motion. Uniform circular motion. Okay? What is uniform circular motion? Uniform circular motion is the motion in which if an object moves along a circular path with uniform speed, that is uniform circular motion. If an object moves along a circular path with uniform speed, such type of motion is known as uniform circular motion. Right. So, what we are discussing now? Now we are discussing about the movement of the stone along the circular path. When an object moves along the circular path, there is change in velocity or acceleration. Okay. So, what changes the velocity or acceleration? So, there is some force which changes the acceleration or velocity. That force is centripetal force. Then what is centripetal force? Centripetal force is the force which causes acceleration and that keeps the object along the circular path with center. So what is centripetal force? Centripetal force is the force which causes acceleration and keeps the object along the circular path towards the center. Okay, so that is centripetal force. So centripetal force is the force which causes acceleration and that keeps the object along the circular path. So which force keeps the object along the circular path? That is centripetal force. And which force causes acceleration? Centripetal force. So centripetal force is the force which causes acceleration and keeps the object along the circular path. So centripetal force is the force which causes acceleration and keeps the objects along the circular path. So if an object moves along the circular path, so that movement of the object is due to the centripetal force. Centripetal means center seeking or center loving. So that force is, acting towards the center. So centripetal force is the force which causes acceleration and keeps an object along the circular path. So that is centripetal force. Centripetal force is the force that causes acceleration and keeps the object along the circular path acting towards the center. So this is a center seeking or center loving force. So centripetal force is the force which causes acceleration and keeps the objects along the circular path acting towards the center. So the centripetal force is the force causes acceleration and also it keeps that object along the circular path. Centripetal force is the force that causes acceleration and keeps the object moves along the circular path acting towards the center. Okay, so that is centripetal force. Then come back to our previous examples like planets are revolving around the sun, high tides, low tides, and the force which binds us on the earth. Okay, so I told you there is a common force acting on these examples. There is a common force in these examples. That common force is gravitational force. That common force is gravitational force. For example, I'm standing, right? Why I can stand? I can stand because of friction and the gravitation. But at present we are discussing about the gravitation. So you don't want to mention about the friction. We can discuss on the basis of the gravitation. I can stand on the floor, that is due to the gravitational force on the floor or my body, which means the earth is attracting me towards its center. Every object in the universe attracted by the earth. See, apple falling down. Why the apple falling down? Because earth is pulling or attracting apple towards its center. So whatever object on the earth is attracting or pulling that object towards its center. So that attractive force is actually gravitational force. Okay, when I am sitting on the chair, earth is attracting my body towards the center, that's why I can sit. So whatever objects on the earth always pulls or attracts that objects towards its center. That attractive force is gravitational force. So how we define a correct statement for the gravitational force? Every object in the universe attract each other. Every object in the universe attract each other. That attractive force is gravitational force. Because of that attractive force, we have existence. Why we can able to, stay in our positions? That is due to the gravitational force. You may heard about the incidents in the space. Why the objects are floating on the space? Because there is no gravitation. If there is no gravitation, the objects floats. There is no, their own position. Okay, it floats to, in different region or different positions. So why the objects are floating? You may see that inside the space, in the spaceship, Why that objects are floating? Because there is no gravitation. So from this you may understand about the importance of the gravitation. If an object sitting somewhere, or if an object standing somewhere, or if we keep an object in some corner, why it is staying there? That is due to the gravitational force. If there is not such gravitational force, what you can see, every object like floating here. And so even we also, can we stand? Can we walk? Can we sit? No, we always flies. So which force responsible for the correct position, or for for maintenance of the condition of the earth? That is gravitational force. So what is gravitation? Every object in the universe attract each other. This force is known as gravitational force. Every objects in the earth attract each other. That attractive force is known as gravitational force. Because of that attractive force, the objects stays in their own positions. If there is no gravitation force, all the objects floats. Right, so earth always pulling the objects towards its center. Earth always pulling the objects towards its center. That pulling or that force is known as gravitational force. This gravitational force bind us. Bind us means this gravitational force connect us on the earth. This gravitational force connect us on the earth, or bind us on the earth. Okay, now we can discuss about the very important point, universal law of gravitation. Universal law of gravitation. Actually, who introduced the concept of gravitation? That is Sir Isaac Newton. Isaac Newton made made lot of concepts related to the gravitation. He introduced the concept gravitation. Right. So what is universal law of gravitation? Universal law of gravitation states that every object in the universe attract each other. Every object in the universe attract each other with a force which is directly proportional to the product of their masses, and it is inversely proportional to the square of the distance between them. Every object in the universe attract each other. That attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So every object in the universe attract each other. That attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. For example, two objects A and B, this is A and B, with the mass, capital M and small m. Why capital M, small m? Because two different objects, big object and small object. So big object capital M, small object small m, and distance D. So two objects A and B with the masses M, capital M and small m, and the distance between A and B, D. So according to universal law of gravitation, A and B attract each other. A and B attract each other. Every object in the universe attract each other. That attractive force is directly proportional to the product of their masses. Okay, so which symbol we can use for force? F. So F is proportional to product of their masses. Product means multiply. Product means what? Multiply. So which are the two forces? Which are the two masses? Capital M and small m. So their product capital M into small m. So every object in the universe attract each other. This attractive force is directly proportional. Directly proportional to the product of their masses. Product of their mass means multiplication. Okay, product of their masses, and it is inversely proportional. Inversely means 1 by. Inversely proportional to the square of the distance between them. So here the distance is d. So the square of the distance d square. So 1 by d square. So this is the equations of universal law of gravitation. So every object in the universe attract each other. Every object in the universe attract each other, this attractive force is directly proportional to the product of their masses and it is inversely proportional to the square of the distance between them. It is very important, okay? Every object in the universe attract each other with a force which is directly proportional to the product of their masses. So the force is directly proportional to the product of their masses, product multiplication, okay? So m into m, product of their masses, and 1 by means inversely proportional, okay? So this means inversely proportional. So the force is inversely proportional to the square of the distance between them. So every object in the universe attract each other. This attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So every object in the universe attract each other. This attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Clear? F is proportional to m and product directly proportional to the product of their masses means F is proportional to mm, and inversely proportional to the square of distance 1 by d square. Okay, then together F is proportional to m by d square. Okay, we can write these two together. F is proportional to mm by d square. So next our task is to remove this proportionality sign. How to remove the proportionality sign? You can remove the proportionality sign by keeping a constant. So here that, so after removing the proportionality sign, equal to, then constant. So here that constant is capital G, mm by d square. So this is the mathematical formulation for gravitational force. Gravitational force F equal to G mm by d square. Here F is the force, G is the constant of proportionality. What is the name of this constant of proportionality? Gravitational constant. So which is the name of this constant of proportionality? Gravitational constant, capital G. Then two masses and distance. So according to universal law of gravitation, every object in the universe attract each other. This attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So universal law of gravitation states that every object in the universe attract each other. This attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So consolidating these two, F is proportional to mm by d square. In the next step, we have to remove the proportionality sign by keeping a constant. So F equal to, and here the proportionality constant is capital G. Capital G, gravitational constant. What is the name of this? G, gravitational constant. So here the proportionality constant is gravitational constant. So F equal to G mm by d square. So which is the mathematical expression for gravitation or universal law of gravitation or gravitational force? F equal to G mm by d square. So how to state the universal law of gravitation? Every object in the universe attract each other. That attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So what is G? G is the proportionality constant, gravitational constant. G is capital G is gravitational constant. So now we are going to make an equation for G. For that, first you cross multiply this. F into d square equal to G m. F into d square, cross multiplication. F into d square equal to G m. Then I am going to write, G m in this side, then F into d square. Then what is G? G equal to, take this mm down. G equal to F into d square by, so what is the equation for gravitational constant G? G equal to F d square by mm. So this is the main equation, F equal to G mm by d square. Then we are going to make an equation for G. For that, first you cross multiply F into d square equal to G mm. Then write this G mm this side and F into d square opposite side. So G equal to F d square by mm. So take this down. Okay, so capital G is gravitational constant. What is G? Capital G is a constant of proportionality, gravitational constant. So capital G is gravitational constant. Okay, and now we are going to make an SI unit for the capital G. How to make the SI unit for capital G? We can give the SI units of these. What is SI unit of force? Newton. The SI unit of force, Newton, and SI unit of distance, meter. So distance square, meter square, by mass, kg, into 2 mass, no, kg, which means Newton meter square by per kilogram square. So what is the SI unit of gravitational constant? Newton meter square per kilogram square. What is the SI unit of gravitational constant? Newton meter square plus kilogram square. How we got that? We can substitute the SI unit of this. Force Newton, distance meter square, mass kilogram into kilogram. So the SI unit of G is Newton meter square per kilogram square. So what is the unit of capital G? Newton meter square per kilogram square. What is the unit of gravitational constant? Newton meter square per kilogram square. What is G? G is gravitational constant. What is G? Gravitational constant. And G is a constant, which means there is a value, a constant value for G. There is a constant value for G. So wherever we go, we can use that same value for G. That is constant. Constant value means what? The value does not change. Wherever we go, we can use the same value for capital G. So capital G is a constant, and the value of capital G is 6.673 into 10 raised to minus 11 Newton meter square plus kilogram square. So what is the value of G? The value of G, 6.673 into, don't forget, okay, 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. So what is the value of gravitational constant? 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. So wherever we go, we can use the same value. Okay, so gravitation, G, capital G is a gravitational constant, and it's a constant, and there is a value for the gravitational constant. That value is 6.673 into 10 raised to minus 11 Newton meter square per kilogram square, and this value found by a famous scientist, Henry Cavendish. So who found the value for G? Henry Cavendish. So the famous scientist Henry Cavendish found the value 6.673 into 10 raised to minus 11 Newton meter square per kilogram square for capital G. So what is the equation for capital G? G equal to FD square by mm. And what is the SI unit? Newton meter square per kilogram. Newton meter square per kilogram square. And what is the value? 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. Who found this value? Henry Cavendish. And what is the equation for force? F equal to gm by d square. And what is universal of gravitation? Universal of gravitation states that every objects in the universe attract each other. This attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. F equal to gm by d square, and G is a gravitational constant, and the SI unit of G is Newton meter square per kilogram square, and the constant value is 6.673 into 10 raised to minus 11 Newton meter square per kilogram square, and the value found by Henry Cavendish. Okay, so that's all about today's class. We just introduced the topic gravitation and universal law of gravitation. We will discuss more points about the gravitation in our next class. Till then, it's bye. Thank you for watching. Have a great day.